Hey everybody, this is Larry. This is me going over Q3 of the bi-weekly contest 54, largest magic square. Hit the like button, hit the subscribe button, join me on Discord. We go over the problems actually right after the contest, after every contest, so come check it out on Discord because I just like having people to talk to and do the contest together afterwards, not in a cheating way, of course. Anyway, yeah, so the problem is largest magic square. And the short answer for this one is brute force, but it's slightly smarter. The thing to note is that the number of rows and columns is at most 50. So that means that at most it's going to be, there are going to be, how do I say this? N cube, let's say the number of rows and columns are equal to 50, then it's going to be N cube number of magic squares to check. So then it becomes, okay. And so if you're able to do that in linear, of n times, then everything will be n to the fourth. That's basically the key observation for this one. I worried a little bit about Python performance. I think it probably would have been okay, but I did worry about it, so I did it in C#. And actually, if you look at the performance, this was my worst problem by far. I spent about an hour and change on this one because I had some silliness with breaking out the loops that I did not notice or debugged for a long time. You could watch me solve this live, but probably fast forward because I spent an hour on it and it's not that interesting to run an hour. You could kind of look into that and see if you could spot the bug as I solved it. But yeah, so this is, the idea here is just keep everything fast enough. Because if you do something like n to the fifth, it's going to be too slow, but n to the fourth is okay. And this is where you pull a calculator and you do, okay, what is n to the fourth, where n is equal to 50, right? And 50 to the fourth is of 6.2 million-ish, so that's going to be fast enough. But I was worried about performance again, as I said in Python, because I don't know how many test cases you're going to give me. And this was easy to write in other languages, except for it's not for me, because apparently I got out of bounds. But basically, yeah, for this one, we take advantage of prefix sums, one for the rows and one for the columns. And then for that, we just have to check each row and each column matches the same sum. And of course, the next question is, okay, what about the diagonals? And this is something that you have to kind of, I don't know if I'm going to explain this too much, other than that if you're struggling with understanding this portion, definitely practice your prefix sum problems. The idea is, the main core idea about prefix sum is just caching it in a way such that, I think I actually explained this recently on a daily problem, but let's say you have a sequence of numbers, let's say you want to get the sum between two indexes, a sub I plus 1 plus a sub I plus 2 plus ... plus a sub j, right? Let's say you're trying to get this sum. Well, this sum is just equal to a sub 0 plus a sub 1 plus ... plus this minus right? So basically, if you have this equation, you minus this equation, then you get this equation, right? So that's how you get the sum within a region in all of one time, because you can solve this with a prefix array, keeping track of the sum of the first x number, meaning the sum of the first zero number, the first sum of the first one number, and so forth. I know that I'm going really fast about this part, but this is something that comes up a lot, at least in Leetcode. I don't know about interviews that much, to be honest, for this particular thing, but it does come up a lot for Leetcode these days for whatever reason. So I'm not going to go over it too deeply, except for, what I just did. That's the idea behind it. And so basically I did it both for each row and each column. Originally I did it for diagonals as well, but you actually don't need it. I think I was just too... I don't know. I need more sleep, perhaps. But yeah, but this is the rest of the code, which is that, okay, for each for each I is equal to j. So this is now for each corner, each upper left corner, if you want to call it that, of the matrix, and then I brute force on k, which is until it goes out of bounds. Again, I calculated this one incorrectly during the contest, but mistakes were made. But in any case, yeah. So now this is this is the sum of one of the rows. This is the sum of one of the rows of the new segment, and this is the prefix rows. And then now we just do a brute force on each possible row within that magic square to see if it is good, and also that the column has the same sum as well. And then we also just do the sum on the diagonals, and if the sum on either of those don't match, we set it to not good. And if it's good and it improves on our answer, we set that to the best answer. And that's pretty much it. So this is a very brute force problem. The only key observation is about the prefix sum. So yeah, I don't know how. I mean, you can watch me solve it live next during the contest. I'm really ashamed about this one, to be honest, because I knew how to do it immediately, and I took an hour, more than an hour to solve this one, more or less. And I don't know. It is what it is. Sometimes you have just bad days. So yeah, let me know what you think, and you can watch me solve it live during the contest. I recommend fast forwarding a good chunk of it. Maybe watch the beginning, watch the end. I don't know. Do whatever you need to do. You're smart. I'll see you later. That. Hope I'm not off by one. Okay. Really worried about that one, to be honest. Otherwise, it would have been faster. Every row column, the size of the largest matrix square. I mean, I think it is what it is. And to the fourth. I mean, it's just prefix sum, but it's just potentially very messy prefix sum. really the same. What am I doing? Not bad. Yep, that's fine. Is this one true? I always forget about diagonals. Yeah, this is so annoying, but okay, fine. Nope. What is this? Okay, so at least it's compiling. Diagonal one is the one that I'm gonna struggle with. So maybe I don't need it. I think I was trying to think about the diagonal another way, but then I think I confused myself. I think this is good enough. Yeah, okay. Okay. actually don't remember how to print stuff. It's something like that. Oh, whoops. That's why you don't copy and paste. You messed up in one place, you messed up in another. What is that? White line. Okay, so I haven't used C# in a long time, so I think this is probably okay. Well, sure. Okay. Do I have to convert? Okay. Oh, I have to. Ugh, yuck. I forgot. Because of all the indexes. Really slow on this one. Lucky I debugged it though. But okay. A lot of people got in it. Like that. That's very awkward, but okay. I guess we start with 1. He's smart. I don't think so. That's not right. So that's not right. What am I doing? I don't think this is right yet, but it should give us a wrong answer in a code, ideally. But it's not. It's just going to be so. That's not good. There's just so much indexing things. Why is this not good? Look at my columns, right? I mean, you should at least give me one, right? Like one cell should be right. Is my prefix columns wrong? my prefix columns are definitely wrong if I'm getting negative numbers. Why? Tell me why. Just 2, just 7. Debugging on this one's amazingly hard. We're going to look at 1, so this should be 7. This should give us 7, but instead it's giving us -5. Prefix. Oh, well, no, okay. I'm just printing the wrong thing out. So maybe that's not wrong. I'm just being dumb. So 9 minus 7 is 2, which is right, but that means I'm doing it off by 1 on the indexing. Okay. Because the match is 1. So okay, so I'm off by 1. I think what I needed is that's why I usually do it this way, but today I was trying to be lazy and that was terrible as a result. I think this is still off by 1, but I just want to run it real quick. Now I have a lot of off by 1 possibilities, to be honest. I have to come and audit my code real quick. I see what I'm doing wrong at least. I hope I already finished the contest, but I guess it is what it is. I just do this. I know that I don't handle the diagonals, but at least it should give me the wrong answer in an optimistic way. So my answer in theory should be bigger than the right answer. But if it's returning 0, then that's not a good thing. So 0, 0. No, I just didn't print out the right one. Okay. So this is giving me 9 and 7. So this and 1. So I'm having the same issue because I'm doing off by 1 again. I need to, my indexes are really bad. But now I'm worried that I'm not going through all the elements. That's okay. That's why you debug before it gets too crazy. So this is it should still return at least one. Why? This is sad. Larry is sad. Also, why does... Okay, so these are now wrong because of the rows. Conceptually, this is not a hard problem. I know what to do, but I'm just really slow today. Okay. So some zeros. No, I don't even think that matters yet. Let's double check. 0, 0. It's giving me 2 for the match. No, it's giving K is 2. Why? Did I run it? So 0, 0. K is K is 1. Why is K not? What? Why am I off by 1 in so many places? Okay, so why is K 2? This is just one of those days. Okay. K is 1, match is 0. Why is that 0? Okay, because we're at 0, 0. That's fair. So then now we want it to start from 1, 1. Okay. So match is always going to be 0 in the first row, which is fine. I think we're having off by 1, but that's okay. I don't know what's going on with my code. Okay. So now we're trying to go one cell. I think the off by 1 is, okay. I think this is still just wrong. This is this minus 1 and this minus 1. I think what's the big deal? So I was off by 1 in the other direction. That's one real quick. This is mostly done. It's just some debugging. I just need to put in the diagonals, which is easier said than done. But like I said, implementation. The strategy is pretty straightforward. Oh no, still wrong. It's okay. 1, 1. The match is 7. That's good. But it's telling me that something else is wrong. Is it on the columns or? Okay, so the row. How can this be wrong? Oh, I need the prefix part as well. The rows are right. Wow, so easy to be off by one on this one, it seems like. Come on. Oh, still no good. Why is this no good? Doesn't it do... So, 1, 1... Oh, whoops. Well, okay. That's a silly one. Okay, so at least it gets 1 correct. But ideally, it should at least get the 5 correct as well. So where's the 5? The 5 is at 1, 1, so that's 2, 2. 2, 2 of length 2. Why does it not try 2, 2 of length 3? Should anyway. Oh no, I'm looking at 2 different. Okay, so this is the other problem. The second question. Okay, so 2, 2, 2. But it should also go to 3, so maybe I'm off by 1 here somewhere. Clearly. Okay, so now this is giving me 3 and 2, which is good. Is it giving me the right answer? Let's see. I mean, it's not good enough, but it is a good start. Let's see. Let's make sure that it is the right index. This should be 2, 2. Yep. And 2, 2 on the next one too. Yep. Okay. So now we got it correct, except for we have to check the diagonals, which is the part that I'm scared about, of course. Okay. So if prefix D1 so we want to count from I minus 1 j minus 1. Oh, this doesn't have to be a thing. Doesn't have to be in part of the loop because there's only one diagonal. So if prefix d1 of I plus k minus 1, this one's gonna be murder. Alright, let's run it real quick so I could procrastinate. Okay, so it still looks good with respect to that. Okay, so now it is if I plus I could probably just write a for loop in it. It'll be, if I get it wrong, I'm gonna write a for loop. But okay, so this is okay. So let's start to start. So this is start. Nope. I don't know. Yeah, at this point I'm not so sure on. Because nope. So we end here, but maybe I should run a folder for this instead. Okay, so we do have negative numbers again. Why is that? Did I do it the wrong way? So yep, I did it the other way. Okay. Still not good. This no, this is. So this is. And then the other one is on. I mean, we should obviously still not have negative numbers though. So what is the 2, 2? 12 and 3. So that's 12. Is that right? That doesn't seem right. So 2, 2 of 1 is 3. I don't even know where that 3 comes from. 3 and 1. Oh, it's here. So it's off by 1 for 2, 2. Okay. I could deal with that. Yeah, okay. So that was the reasoning, because this padding is wrong for this one. That's pretty much why. Okay. The prefix diagonal is not necessary. We can also just sum diagonal. What's it called? I think this is wrong too. Okay, so this is. Oh no. Oh yeah, because this is based off this indexing. Okay. This is very awkward. Okay. Give it submit. Oh no, come on. Come on. Hitting test cases. What do you think you're doing? You think you're cool? What a mess today. Oh, this is gonna overflow, isn't it? No, that's not. There's only 50 numbers. Wish they gave us the thingy though. I don't know why this is so awkward. Oh, plus K. Plus L, rather. Now I'm like worried about all of these things. I'm gonna get so many wrong answers from this one, just because. This is a struggle. YOLO. Okay, still the wrong answer. So why is this wrong? I could get the diagonal right, at least. Well, this one is really wrong. So I'm not surprised. Why is that just 0? Straight up 0. Oh, because we break early, so maybe that's why. We break early, that shouldn't matter. One, 4, 2. is this giving? 1, 1, 1, 4, 2. That's should be 11. 11. Okay, that's right. 11, 11. But this is 10 going the other way, so it's already false. But what's the diagonal? Diagonal is 9 and 12. Is that what I get? 5 and 6. That's not good. But that's because we terminate early. Because I think this is just well. 9 and 12. Okay. So I think. Yeah. Do I get the right diagonals right? Or the columns right? Maybe that's the only other thing. Is if this is on a corner. Okay, so let's still 3, so that should be good. Let's add an extra one. I don't know why I'm wrong then, other than time limited or something. Only 50 elements, so it should not overflow. That's the only thing that could be wrong. Man, I am struggling with this one. Yeah, it's still giving me the right answers for these. And that's the only thing that I could think of that's wrong. Other than overflow, but yeah, only 50 million. I had to double check just because I don't know what else to check anymore. But I didn't change any code. Disaster. Why? What can be wrong? I really do things really dumb now. Right? Try at least one number. So. I don't get it. Tell me why. I don't get it. Why is this wrong? Oh my god. Okay. Let's see if I could skip ahead. I spent an hour on this, and I still don't get it. This is what a disaster. Wow, people got it in 2 minutes. Okay, let's see if I could get this real quick. Oh my. I still don't know how to do this one though. Grant me strength. Like, what am I doing wrong? This is literally just 4 loops. I really don't know. There are no negative numbers. I'm not. What am I doing? What am I doing wrong? How can I be wrong? That's right. How can this be wrong? What am I doing wrong? Wah, wah, wah. No, the best is not okay. If this is the reason, I'm gonna be a little bit sad, but I don't think that would be. Let's at least test one more cases before I YOLO more. Should be 45. I don't know if this is right. I forgot how many time I pasted. Let's give it a submit. Okay, it's still wrong, but why? This is just for loops. I don't get it. I don't get it. Yikes. I think this is gonna give me an exception if I'm correct. Nope. No, I guess that's right. I don't get it. I don't get it. I don't get it. I just one of those days. I really don't understand why. Did I misunderstand the problem? Okay, they don't have to be extinct. Okay. Every column sum, row sum, the side length k. I don't get it. What am I getting wrong? This is not a hard problem. I mean, I took a long time because I'm an idiot, but prefix columns, prefix columns. Maybe that loop was wrong. I think skip the case where it is longer than or. I have to be careful. Okay, so I was just being too stupid on this one. Okay, I get it. Oh my god.